It's Wednesday. No, it's not. It's Thursday. And we are continuing the 4.1 notes. Yesterday we did scatter plots. So I want you to scroll down in the 4.1 notes all the way till you get to this part called correlation. All right, correlation is the term for how strongly the dots from the scatter plot are in a pattern. So like if we have the dots like this, they're all pretty close to being on a line. That would be a stronger correlation than if the dots were a little bit more spread out. Now that still is a linear relationship. It's still a positive linear relationship, but they're not as close to that line. So it's a weaker correlation. So this is not just an estimate. This is an actual calculation. And you see that we've got this giant formula here. Correlation is written as R. So where do these letters come from? The X and the Y are from the coordinates of each dot. The X bar and Y bar, that would be the average of the X's and the average of the Y's. And then you have your S of X and S of Y. That's standard deviation. Here you see the summation symbol, which is why we did that summation practice. And then we're going to multiply it by 1 over n minus 1. All right, we've got step 1, find the mean and the standard deviation. So that's how we get x bar, y bar, standard deviation y, standard deviation of x. That can all be done on Stablet or in your TI calculator. Then step 2 is to standardize the x and y values. Now that's just z-score. And remember the formula for z-score was x minus x bar over standard deviation. X minus x bar over s. That's what's happening right there. So we're going to standardize the x's. We're going to standardize the y's. Then you multiply each of those scores for each product. So we're multiplying 12 times if we have 12 dots. And then after you add all that up, then you do this n minus 1 step. Okay, I know it sounds like a lot. So we're going to go through it step by step together. We are going to find the correlation for the hikers data from earlier. Okay, so let's start by finding the mean and the standard deviation for both x and y. So let's use, most of you seem to prefer Stablet. Oh boy. So we're going to go to we're going to go to quantitative variable. Let's do the x's data. So you're going to put in x's was body weight. So 120, 187. Okay, analyze that. So here we've got our mean and our standard deviation, 139. None of these are the right one. Okay, so x bar was 139. And standard deviation was 31.5. Okay, repeat that process for the y's. And it is important that you keep these in the same order that the x's were in. .6 and 3.5. Okay, so now we're going to standardize each of those values. So I'm going to take the x value, subtract, so we got x's, we got y's, subtract the mean, so it would be 120 minus 139 divided by 31.5. 120 minus 139 equals divided by 31.5. So my standardized value for x is negative 0.6. And that's from the 120. The y coordinate that goes with that is 26. We're going to standardize that. So we'll take 26 minus 28.6 equals, and then divide that by 3.5. And I got negative 0.74. Okay, so do the same thing with 187. 187 minus 139. Divide that by 31.5. I get 1.52. And then I'm going to do the same thing with 30, because that's the y coordinate that goes with it. So it's 30 minus 28.6. And then divide that answer by 3.5. And I get 0.4. So I've got my y coordinate column. I've got my standardized x coordinate. And my standardized y coordinate, and we're just going to continue that down. Okay, so here I have the table of all these standardized scores. I've got my standardized x's and my standardized y's. Now we're going to do step 3, where we multiply the standardized scores for each individual and then average the products. So I'm going to make another column, and then it's going to be x times y. Okay, so I'm multiplying the standardized value. So here I'm taking negative 0.6 times negative 0.74 and getting 0.444. Okay. And then I'm going to take 1.52 times 0.4 and get 0.608. Okay, continue that. Okay, so there's the rest of that column. The x is actually the standardized x's times the standardized y's. And then we're going to average the products. No, we're not. We're going to add up all the products, and we're going to divide by n minus 1. We're not dividing by n, so it's not quite an average, but close to it. So we're going to add up that last column. When I added them all up, I got sum equals 5.2779. So that is this part right here. It's the sum of all of the standardized scores multiplied together. So now we're going to do 1 over n minus 1 times 5.2779. Now n is the number of points on the scatter plot. It's not, so there's 9 of them. No, 1, 2, 3, 4, 5, 6, 7. There's 8 boys. N is 8. Not, there's 16 numbers, but 8 of them are x's and 8 of them are y's. So it's 1 over 8 minus 1 times that. So let's see, that number divided by 7. So our answer is 0.754. That is our correlation coefficient. That is our R. All right? And that's as far as we're going to get today in the notes. How to calculate R.